How do you charge an air conditioning system in a mobile home? This is a trailer unit. Today I'm going to be giving you tips on charging, talking to you about the most common places you'll find where it's leaking, and I'm going to give you tips for installation if you're planning on installing a new trailer unit, what tips you should know when you're installing a unit like this. You're watching HVAC Tips for Technicians. I'm Tad. Let's get started.
Okay, so this is a trailer coil, and you can actually look right here. It says Nordyne, so this is made by Nordyne. You can see the model number. See, it says C3QA/036. So 36,000 BTU. This is a 3-ton trailer coil. Where do you find leaks? Inside this coil. You can see all the rust that's accumulated at the very bottom. You are going to find that it is going to start leaking right here in these areas. And usually you want to install a new coil. Typically for installation of a new coil, it's going to be around $1,500. That is installed. Sometimes it's around $2,000. But this is where I find most of the leaks in trailer units. It's in the indoor coil. Now this right here is the metering device, and there's an orifice in here.
How can you tell if the system needs refrigerant?
Checking superheat, of course, but you also know when you turn it on cooling, you only see these U-bends producing that sweat, and they're cold. And then up here, you can tell there's no refrigerant because, of course, there's no condensation. There's no cold. It's warm up here.
This is what we call a dry coil. If you say a coil is dry, you mean that it's empty. If you say a coil is flooded, that means it's full. And we can clearly see that half of this coil has condensation on the U-bends, but the other half does not. So I know for a fact that we have a dry coil. It is half empty. It is not flooded. It is not full.
And the refrigerant enters in through the liquid line right here, goes through the distribution tubes, and then it goes through the coil and then comes out of the outlet pipe, which is the suction pipe, the vapor line. And it's supposed to enter a liquid and then exit a vapor. Let's go look at the charge. We'll come back in. I'll give you some more tips. Here's the outdoor unit. This is straight air, so it's got air conditioning, and then inside we've got electric heat strip. So it's not a heat pump, doesn't have a reversing valve. Here's our gauges. Low side is in between 50 and 55, and then high side is about 220. So 50 and 220. So what we want to do is feel this vapor line and see how cold it is. Not very cold. It's only 74 degrees, 73 degrees. Got the thermocouple, the clamp. Here's how the gauges are hooked up, or the hoses. And then I always feel the liquid line. If the liquid line is hot to the touch, then it could mean that this coil's restricted. That means it's dirty. It may need to be cleaned. If this line right here is super hot, but it's not. And typically when this line is really hot, then the high side pressure is usually really high, okay? So, but it's not. We've got 74 degree vapor line, and then if we look our saturation temperature, which is the pink line, it says saturation is about looks like zero. So that's not good, because 0 and 73, it looks like it's about 70 degrees of superheat, and we need about 10, right? 10 or 15. If you don't know how to check superheat and subcooling, I've got a video. I'll put it down, the link in the description, so you can learn how.
This unit right here is R22, so we're using a retrofit refrigerant, a replacement for that R22, and I'm going to show you that. I got the scales hooked up, so we're ready to charge.
So this is what we're using, 422B. I've got my scales set up, SR47. Now what I'm going to do is I'm going to zero out the scales, and then I am going to bleed this Zero it out one more time. And I'm gonna add through the vapor line, okay? So here we go. Open this up and this up. Okay. And you can see as I'm adding, the head pressure is gonna go up, right? You see that? I'm gonna lower it as I monitor that head pressure. And look at that. Pressure's already 65, in between 65 and 70. Let me talk about what pressures I usually see. And we've added about 13 ounces, so almost a pound. The pressures that I see normally on a 95-degree day, for the low side, suction pressure is usually around 70. The head pressure is usually around 250. So low side pressure 70, high side pressure about 250. Now it can be different depending on the indoor dry bulb temperature and the outdoor ambient conditions. Sometimes when I have a 95-degree day, if it's 80 degrees in the house, then my suction is usually about 80. And then if it's 85 in the house, my suction's about 85. So the inside temperature, you will see that reflected on the pressures on your gauges. So as you learn, you do more calls in the field, you're gonna understand more, and you're gonna be able to kind of figure out where your charge needs to be based off the inside and the outside temperatures. Now our low side's 65, high side's 245, and our vapor line temperature getting colder, 69 degrees. Okay, liquid line still not hot, not even that warm, so that's a good sign. I'm gonna add a little bit more, try to get us to that pound. Okay, we're at a pound. How do we know? Units, 1 pound, 4 ounces. Okay. Let's go in and check that indoor coil now. Low side is about 70. High side's about 260. Okay, so take a look at this coil. Now you can see the condensation here. Oh, up here, up here. Okay, it's condensating on all the U-bends now. So an easy way to tell if it's low of refrigerant, go inside, see if all the U-bends are sweating. See if it's cold all the way to the top. Because now you know the refrigerant comes into the bottom of the coil and then it exits the top of the coil here. So these indoor coils have to be cleaned sometimes, and there is an easy way to do it and a hard way to do it. Well, not really hard, it's just a way that takes a little bit longer and it can cost more money. I'm going to talk about both of those ways right now. The first way that I like to clean these coils is I like to leave the coil in here. I like to talk to the homeowner first about the two different methods. And once they choose the easier option and the cheaper option, then I get towels. I get 5 or 6 towels. I've got a short video on how I clean the indoor coil in a mobile home unit. And I'm actually going to put that in the link in the description so you can check out that video of cleaning an indoor coil. But one method is leave the coil in and stuff towels on each side, inside here. And then put towels on the floor in front of the actual electric furnace. That way you don't get a bunch of water everywhere. And then you leave the coil in and you spray it with coil cleaner, and then you clean it while it's inside. You have a shop vac in here as well down on the floor next to the electric furnace. That way any of the water that doesn't get soaked by the towels, then you can suck it up with the vacuum. Now I'm going to talk about the other method as well. So I would put towels down here, I would put towels down here, a towel in front, and then I would take this panel off right here, right? And of course you want to turn the breakers off, but I would put a towel over here, a towel over here, and then a towel over the blower motor. And the reason that I'm leaving the coil in here is because the other method is taking the coil out. You see, you've got these connectors right here you can take loose for the vapor and the liquid line, but you might not be able to pump the refrigerant down. You might have to recover it, and that can take some time. So let me explain to you why you couldn't pump the refrigerant down. And look at this, look at this, look at it sweating all the way down now. We can definitely tell that our coil is filled with refrigerant. Now we're going to check vapor line temperature, but first I'm going to show you one of the reasons you can't always pump the refrigerant into the outdoor unit. So the reason you might not be able to pump the refrigerant down is because you don't have valves out here. You see, there's no suction line or liquid line service valve. So you can't close off the liquid line and the suction line, isolating the condenser from the line sets and the indoor coil. So if you can't pump the refrigerant down and you've got to recover it, it's going to take more time. It's going to cost the customer more money and labor. And you don't want to cost the customer more money if it's easier just to put towels next to the furnace and get the coil clean quicker. That's the best option. Now check out that vapor line temperature, 62. And look at this, sweating, nice and cold. Low side pressure is now 70. High side pressure is 255, in between 255 and 260. So if we take 62 now, almost 61, and we're looking at our saturations about 15 and 60. So we're getting close to 10 degrees of superheat. We may just need to wait a little while and see what happens, because this temperature is dropping. I'm going to add a little bit more refrigerant. I don't think I need much, maybe 1.5 pounds for this system. All right. Right now we've got 1.5 pound, 10 ounces. We're going to let it set for a minute and then come back and check it. This is the thermostat, old Mercury style. It's on cooling, auto for the fan. I cannot even tell the inside temperature. Definitely need to install a digital thermostat. I've got my dual In-Duct psychrometer measuring the supply temperature. And what was that vapor line temperature? It was about 61. And that's what we're seeing on the supply vent, 60 degrees. So I wonder what the room temperature is.
Installation tips for installing a new split system in a mobile home. So you get a trailer coil, a trailer electric furnace, and a new condenser. Make sure you get new line sets. Always order rolls of line sets. They come in 35-foot length, 25-foot length, 50-foot length, depending on your supplier. They will have some pre-insulated line sets that you can order. Make sure if you're installing a new split system in a trailer that you install new line sets. The next tip is make sure you have enough return. Now, if you've got a 3.5 ton or a 4 ton trailer split that you're installing, let me explain to you what you may have to do. And if you don't do this, you're not going to have good efficiency from that new split system, right? Let's check it out.
So this is your return grill, right? Right here. Air comes from the home into the return grill, down through the coil. Now, if you have a 3.5 ton or a 4 ton unit, you need more return than just that return grill that pulls air into that electric furnace. And when you order a new furnace, it's going to have a filter rack up here. And there's going to be another filter that slides right here, right? So what I do is, on those new split systems that I install in trailers, I always carry a 20 by 20 return grill, and I cut a hole up above the furnace and I install another return right there. Why? Because a 4 ton unit is not going to work well off of that, looks like 20 by 25 return grill. It needs more, and that's the reason they install a filter here for the new units and a filter here. That way you have enough return. And most of the time, just like this one, there is no return grill up here, so there is no other return.
Something you may also want to do is you may want to install a return grill that takes the same types of filters or same size filters that is in that mobile home trailer split. That way your customer, your homeowner, doesn't have to buy 2 different types of filters. Because if I install 20 by 20 up here and there's a 16 by 20 down here, then they have to get 2 different types of filters. So that's also something you can do to help your customer and help yourself. Common problems that you will find with trailer units like this. Number one is leaking indoor coils, and you may have to add refrigerant because of that. Not to say that the outdoor unit can't have leaks, it's just I find more commonly that the leaks are in the indoor coil. Number two is you can have dirty blower wheels. The blower wheels can get dirty and it can cause the bearings to go bad on the indoor fan motor. I'll show you that in a moment. You can have bad sequencers. So sequencers control the heater kit coming on, the electric heat strips. Those sequencers can go bad because of course there's lots of amps going through that type of relay and it can burn it up. And you'll also see burnt wires inside of the electric furnace part. You can have bad motors, so bad motors from blower wheels being dirty, or just bad motors from it being a very old motor, or the capacitor went bad. So you could have a bad capacitor, leaking coils, dirty filters. You can have a bad capacitor for the condenser, the compressor's not starting, or a bad outdoor fan motor. Why? Because you changed the capacitor but the fan won't turn. It's hard to turn because the bearings are bad. Let's see, dirty coils. You can have dirty indoor coil, you can have a dirty outdoor coil. This is something that I run into. You need to definitely clean the coils once a year. Also drain. You can have drain issues. And drain issues are bad for these electric furnaces. Why? Because when the water doesn't drain out of the drain line, out of the pan and outside, it drains down beneath. And it can ruin the blower motor. It can burn up some of the components inside, some of those relays. It can burn some of the wires up. And it can cause an electrical fire. So you want to make sure that you have a clean drain. Let me show you where the drain is.
Okay, so this is where the drain is, and I'm actually going to turn the light on so you can see. There's where the drain is connected. See, it's one of those little flexible hoses, and you can see this pan is full of some nasty stuff, so it may need to be cleaned, right? Now, a little bit of a tip here. Anytime you take this panel off and you leave it off, you're going to cause your coil to freeze up. Why? Because you're pulling, you're not pulling the air through the coil anymore. You're pulling the air through here. What does that do? It lowers the suction pressure. And I'll actually show you that here in a moment. There's our blower wheel. Also, it is sometimes really hard to get to the capacitor. You see that capacitor back there? It is hard to get to that capacitor. What do? You take the couple screws, right, loose. There's maybe one there and one on the other side, and then you slide the blower out. You can slide that blower out, okay? All right, let's go outside and look at some other things. I'm going to show you what happens when you take that panel off with the pressures, because our suction pressure was about 70, but I guarantee you it's lower than that now. All right, look at the pressure now. See how it says 60? Right below 60, and our suction temperature is 44, 245. Remember all that. I'm going to go inside and put the panel back on. Okay, now put the panel back on. I'll leave the camera on. Just so you can see how our temperature is going up. 49, 50. Head pressure is going up to 55, 62, 65. And then the suction, look, suction is almost back to 70. So you can see how taking that panel off will affect your pressures. Now it's 54, so it's still going up. Okay. Wow. All right, I'm gonna go check this, the supply air temperature. Supply air temperature is 59. Okay, excellent. Now I'm gonna turn this up and see when it shuts off. Okay, it shut off at about, looks like 80. Right, almost 80. Okay. Now for trailer equipment, if you cannot find a disconnect outside near the unit, it'd be a good idea to install one so you can offer the customer, hey, I'd love to install a disconnect. If you don't want to do that and you want to find the breaker, I can tell you it's at the nearest breaker box that's outside. Let me show you. All right, breaker box, it's right around the corner. Air conditioning. All right, some more tips. So capacitors go bad. How can you tell? Usually they're swelled at the top and they're not flat. Contactors can go bad. If you ever have a customer call and say, hey, the unit won't shut off, it's running all the time, I have to cut the breaker off to get it to turn off. Could be that your contactor's stuck, so that can cause the unit to run all the time. Also, capacitor, of course. You hear your compressor hum, but it's not starting, check your capacitor. If you don't know how to check out a capacitor, I will drop a link in the description on how to check out a capacitor. I checked this one, it's 50/5, and I checked COM to hermetic and it read 50, and then I checked COM to the fan terminal and it read 5. So capacitor is good. How much did the service call, the labor, the refrigerant cost the customer for this service call? It's about 250 bucks. Service call is about $90. 2 pounds of refrigerant at about $48 a pound is about 100 bucks. So service call and refrigerant's about $200. If I'm there for an hour, then I will add an hour labor. So I'll add about 50 bucks. So that comes out to about $250 for that service call. Also on the ticket, I give them a price on a new coil. And if I'm gonna put a new coil on this older R22 system, I need to make sure that I order an R22 TXV. That way it works with the refrigerant. Because if I do order a new coil, usually comes with a 410A TXV. So coil is going to cost me about 600 bucks, 500-600 bucks. TXV is going to cost me about 150 bucks. Then I need to know exactly how much refrigerant the system uses. If I can't look at the outdoor tag because the unit's too old, there's no tag, then I'm going to guess. And I've been doing this a while, so 3-ton, little bitty condenser, probably 4 or 5, maybe 6 pounds of refrigerant. So you make sure you know exactly, and also filter dryer. I need a filter dryer for this system as well. And that's not much, but the total job will cost the customer about $1,500. So they want to go with a new coil, 1,500 bucks. They want to go with a new electric furnace, a coil and condenser, and new line sets, be about 6,500 bucks, something like that. Hope you guys enjoyed this video. I hope you learned something. If you did learn something, let me know what you learned down in the comments. Do not forget to ask a question if you've got a question. Questions can lead to new content, so I really appreciate all the questions. If you want help with your project, you want tech support, click the join button. If you haven't seen my members only videos like HVAC sales training, geothermal training, duct size training, equipment pricing, equipment sizing, definitely go check out those videos. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. Really appreciate you watching. Hit the like button, subscribe, smash that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.